Between severe droughts, sudden trade embargoes, and outbreaks of zoonotic diseases like avian flu, our traditional agricultural systems have been hit hard in recent years. These specific vulnerabilities triggered cascading shocks across global supply chains, leaving empty grocery shelves and skyrocketing prices in their wake. Before 2025, if you looked at things like plant-based burgers or cultivated meat, you likely saw a niche, venture capital-funded consumer trend born out of Silicon Valley. But as food imports stalled, governments realized they had to rethink how they feed their populations. They needed highly resilient, entirely domestic ways to produce protein. Look at this bar chart. Over the last 5 years, cumulative public funding for alternative proteins jumped from $700 million to at least $2.5 billion, spread across 33 different countries. Governments now classify these projects under the strategic umbrella of biomanufacturing capacity, integrating food production with national biotechnology goals. China's state-owned investment corporation committed nearly $1 billion to build domestic biotechnology facilities, prioritizing new proteins. The EU similarly awarded over €100 million in loans to help regional fermentation and plant-based companies scale up. To keep this new infrastructure operational and ready for a crisis, it needs constant, everyday use. That means the food coming off these lines has to taste identical to conventional meat and be incredibly cheap to buy. Consumer adoption is the engine for all this factory production, which means these new proteins have to achieve absolute sensory parity. They have to smell, sizzle, and chew exactly like traditional meat. To solve this, scientists stopped trying to grow 100% cultivated meat from scratch. Instead, they started merging platforms, combining plant-based proteins with cultivated animal cells. As you can see in this ratio breakdown, researchers at Imperial College London proved that adding just 2 to 10% cultivated beef into a standard pea protein base radically improves the texture and overall aroma of the final product. In the lab, researchers can even tune how those specific cells will smell when cooked, simply by adjusting the nutrients they feed the cells during the growth phase. The result of this precise cellular tuning is a highly appealing, recognizable meal that behaves exactly how a consumer expects it to. By combining the cost efficiency of plant proteins with the authentic fat and flavor of cultivated cells, hybrid meats solve the sensory problem and clear a realistic path to mass consumer adoption. But even if the taste is flawless, building a specialized, commercial-scale factory from the ground up requires massive amounts of upfront capital, which is a lethal bottleneck for most startups. One workaround is utilizing drop-in ingredients. A company called Fabumin makes an aquafaba powder from legume byproducts that integrates directly into traditional factory lines, requiring zero new machinery. For those who do need specialized equipment, governments in India, Australia, and Canada are directly funding shared pilot-scale biomanufacturing hubs. These facilities operate as public incubators. Startups can rent time on massive fermenters to test their processes and scale up production without taking on crippling debt. By leaning on shared public infrastructure and drop-in ingredients, the timeline to move a new protein from a lab experiment to a grocery store shelf drops significantly. With the science proven and production scaling up, the final hurdle is getting these new hybridized and cultivated foods legally approved for sale. We are seeing rapid movement here. Recently, food standards authorities in Australia and New Zealand officially approved cultivated quail, while the United States gave the green light to cultivated seafood and pork. These historic approvals established the first clear legal pathways for sales, allowing the industry to move from pilot projects to the open market. This brings us to the ultimate target, a unified global bioeconomy, where producing a steak utilizes the exact same core infrastructure as producing advanced medicines. This provides a functional base for strategic readiness. A facility optimized for commercial food production can be designed to pivot its output to medicines or fuels during a major supply chain disruption. Look at this volume gauge. The UN estimates we need $10.1 billion in annual public investment to fully realize the system. Currently, global commitments sit at barely 10% of that goal. The science works. The supply chains are forming. The blueprint for a resilient, highly secure food system is already on the table. Building it is now entirely a matter of financial willpower.